This video is going to go over a C# program uh, that I wrote really just to practice good C# classes, object-oriented programming. Um, and yeah, so it's, of course, it would be better to break these up into different files. I just didn't do that because um, I think it's easier to look at here. And because I'm doing it in compiling it through the uh, console, it's a little bit easier to not break it up. But anyway, so ignoring that, uh, let's see. So I was thinking of this idea. I just really wanted to practice making some classes and some objects. And I like the idea of thinking of a game engine when I make objects because it's more concrete in my mind and it's a little more visual. And in this case, what I did was when we get down to the program part here, I make two balls, a blue one and a red one. They start out with fixed sizes and in fixed positions. The red one, let's see which one's which. I think it's the blue one. One of these I move and one of them I do not. I think I move, there it is. The blue one moves to where the user tells it to move, and the red one does not move. Technically it moves, but it moves to a fixed position. And it stays in that position every time. So all you really do is you move the blue one into a position, and this thing will tell you whether they collided or not. And it was just really fun to make. So um, going over it here, we have our, well, let's actually start with the program itself. So we create an object uh, of type ball that is named blue ball that has the properties 3, which is the radius. So it has a radius of 3 units and the color blue. Then we write to the console what the starting position of the blue ball is. This was actually just for debug purposes. I wouldn't have had this in there otherwise. And then we ask the user how long they would like the ball to roll for. Then they enter in a time value, and that gets stored into time. Then we ask them what the x-axis velocity of the ball is. That would be the horizontal velocity. And then we store that input in x velocity. We do the same for the vertical velocity of the ball, and we store that in y velocity. Then we do this, we call this move method on the blue ball, where it takes that x velocity, that y velocity, and that time, and it calculates a new position. Then again, this line here is just for debug purposes. We write to the console what the position of the blue ball is. And then we generate a red ball. It's of type ball. It has radius 4. It's red. We have it automatically move to this position here, which will be 12 on the x-axis. So the center of it will be shifted 12 on the x-axis and 4 on the y-axis. This was telling you that it's for 1 second, which was just done to make the, so that it's easier for me to know that it goes to position 12.4 on the graph. Then we write the position again for debug purposes. Then we're going to tell whether a collision occurred or not. For the collision, we use this, we create a new object called, well, colbet W red and blue, which would stand for the collision between red and blue. And this is of type collision detection. It takes two objects as inputs, the red ball and the blue ball. Then we write to the line the center, the distance between, it should be the distance between the center AX. That's it. No, okay, so the center X coordinate, Y coordinate of the first ball, I think I have it, so it's the first ball. So this would be the red ball, and then we have it do it for the second ball, which is going to be the blue ball. So it's just right, and again, this was for debug purposes. And then again, for debug purposes, we write the distance between the x values, the distance between the y values. That gets used in the formula. Then finally, the actual thing that we care about, the distance between the two centers. That's right here. And then because these are always of size 4 and size 3, that means that if the centers are 7 or less, a collision occurred. So if this distance is 7 or less, a collision occurred. And then we say, did a collision occur? Which is really the whole point of the program. And then it outputs the result. So just to give a little bit graphically here what that looks like. So for starters, I'll just put in 1, 1. That's what I kept putting in before. So I'll keep the time at 1 second so that it's always shifted by whatever I type in for the X shift and the Y shift. But this would be the blue ball that moves. This is the red ball that stays stationary. This is going to tell me whether down here should be what the distance between them is. So the difference here is 11, the difference here is 3. So the distance between the two centers is 11.4. And this makes it just really nice. This was again for debugging, because I can easily tell whether a collision should have occurred or not. So let's pull this up here. I already have everything typed in, which this should already be made. It's compiled. We'll run it. The starting coordinates of the blue ball is 0, 0. That's always the case. I had to always generate the ball at 0, 0 initially. Let's have the ball move as in the graphic. Well, now how that'll look. Yeah, that doesn't look too bad. We'll have it roll for the time. I'll just always keep the time at 1 second for simplicity's sake. X velocity is 1, and the Y velocity will also be 1. So the position of the blue ball after the move is 1, 1, which, well, it's harder to, this should be 1, I think, and this should be 1. So this is the center. And the position of the red ball is 12, 4. That's never going to change. So 10, 11, 12, 1, 2, 3, 4. That's right here. The distance between them from here to there is right here, 11.4, which is what we have here, 11.4. Did a collision occur? False. So let's try some different values. Let's see what gives us a collision here. 6 gives us a collision, so let's run this again. Oops, how long? Yeah, we want it to be 1. The x velocity will have 6. Y velocity will have 1, going off my value right here. The position of the blue ball is 6, 1, which looks about right. 6, 1. Again, the red ball doesn't change. It's always 12, 4. This is repeat information. This is not so important, really. That was for debugging. The distance between the two centers is 6.7, which I didn't put that down here. So this has to be a 6, because it's 12 minus 6 is 6, or really just the distance between these two numbers is 6. So we have 6.7, 6.7. Did a collision occur? True, a collision did occur. And yeah, so that's basically all it does. And that was really fun to make. And now I can explain what I skipped over before, which was my classes. So this is just the program running. And I have this ball class here, which has these attributes. So it can have color, it can have a radius, it can have x coordinate, a y coordinate, and a velocity. The color and the radius are private, can only be set privately. They're not intended to be changed anywhere else. So I don't imagine the ball can grow or shrink, or that it can change color. That's fixed when the ball is created. Then we have a constructor here, public ball, takes in two values. That's what we saw earlier, a radius and a color. The radius, that means this radius that's input equals radius that's part of the, that's an attribute. Same for color. we have it started with x at x0, y0. Then I only created one method for this class, and it's the move method. It takes in 3 values, which you saw. Here I don't have them positioned in the same sequence that I had at question. When it generated the questions, it asked for time first and then the 2 velocities. Here it's inputting the x velocity, the y velocity, and then the time. I used doubles everywhere just because it was easier to make the input translate from a string to a number using double. So that's just why I did that. And so we just have this for loop that's basically going to move it the amount of times, whatever the time value is. It'll move it that many increments of velocity. That's all it's doing here. Then the other class I have here is collision detection. And initially I tried to do this different because conceptually to me, I had something kind of different in mind, but then this ended up being how it worked. Maybe there would have been a better name for this than collision detection, but that's what I ended up calling it. It has quite a ton of attributes. In fact, I'm not even sure if I ended up needing all these attributes. I didn't really clean this up once I got it working. So we have the distance between the x values. That should be what I use that for. Actually, I'm not sure. Yep, it's used down here, right here. The distance between the x values, distance between the y values, a Boolean value of whether the collision occurred or not, and for whatever reason I can't use the get set. What would you call that? The get. Anyway, I can't set this up the same way for some reason. I thought that was odd. I'm not really sure why, but it wouldn't let me do that with a Boolean value. We have the center. So we have A and B are the 2 balls. There's the x value of A, the y value of A, the x value of B, the y value of B, the radius of A, the radius of B, and distance is the distance between the 2 centers. So we have this method here, collision detection, and this one takes in 2 objects. It's the 2 balls, and this should be what I use down below. Collision detection. Where did I use it? Right here, detect collision. Same thing. No, that's collision detection, detect collision. Oh, sorry, this is the constructor. That's what's going on. So this is the constructor. And so constructor takes in these 2 values. So I did use that. I used that down here. Takes in the 2 objects, the red ball and the blue ball. And then from those, it sets within my collision detection object, it's going to set the center AX to the X value of the first ball, center AY to the Y value of the first ball, center BX to the X value of the second ball, so on, the radius from the 2 radiuses of the balls, 2 radii of the balls. And then we have, it calculates the distance between the X's, the distance between the Y's, and then it uses the formula, oops, this formula right here to calculate the distance between the 2 centers. And then I have this method, detect collision, which that's the one that I use down here. That's what we're outputting finally at the end as the result. It says if the distance between the 2 centers is less than or equal to the sum of the radii of the balls, then return true because that means a collision did occur. Otherwise, return false. And that is my program in action. We could try out a few more. So this is with one example. So we could try, I did test that it works if I collide it on the other side. 20 is too far, but we can use that anyway. So here it should not collide. Distance between 20 and 12 is 8. So we should have 8.544 as our distance between the 2 centers, and it should say false. How long? We'll stick with 1 second. We'll do 20 is where we want the X to land, and 1 is where we want the Y to land. 8.544, false. If I make this just a little bit shorter so that they collide, we could try like, well, 16 should collide. And we could try something else for the y just for fun. Let's try like 4. So once again, one more time here. One, I can do this, the difference between the x's is 4. The difference between those is 0. That worked out nice. That was 4. So we're going to run it again. And we want it to roll for 1 second. Makes for easy math. And we're going to do 16 and 4. 16. It's a little dark. It's a little hard to see my keyboard. And 4. So we got that the distance between the centers is 4, same as here. Did the balls collide? The answer is true. And you can verify on this one by counting, I believe. So you can tell pretty much the center is right here. 1, 2, 3, 4. That's that center right there.